Welcome to the second video on section 6.4, separation of variables. What you've done so far in section 6.4 is you have found general solutions to differential equations. So each of your answers has ended with a plus C. What we're going to get into next with two examples is to find the particular solution. So the particular solution means that I have to give you an initial condition. I have to give you an initial X and Y value. It's not always, X doesn't have to be zero. By initial value, I mean, I just have to give you a point. I have to give you an XY coordinate pair. And so what we're going to do is we're going to find the antiderivative, and then we're going to plug in this X and Y to find C. There's one more thing that we're going to do here that's a little different, and that's because of this and the instructions. So the particular solution means we actually want to find the value of C. And this little thing right here tells us at the end to solve for Y. We did not do that with any of our examples so far, because you don't need to solve for Y when you're doing separation of variables unless you're told to. But when it says find the particular solution Y equals f of X, we want to find C, and this tells us that we need to solve for Y. This example is already written out for you. If you'd like to print it, it's posted in Classroom with the assignment, or you can take the notes on your own, up to you. So let's jump in, and I actually miswrote it. This should be a -2. So go ahead and fix that if you copied mine. And we're going to start with separation of variables. I'm using separation of variables because we have X and Y in the differential equation. So what we do first is we move the dx to the other side. And then we're going to move y to the left-hand side. So I'm going to be multiplying both sides by y. And so I'm going to have y dy equals x plus 1 dx. Whenever I have multiple terms, I like to put them in parentheses. And by the way, as you do more practice on this, you might find you can skip right from here to here, because a lot of people will see you're kind of cross multiplying. So move the dx up and move the y over there. But it's always okay to show a little more work. All right, our next step is to integrate both sides. I'm going to go ahead and put the integral right in there. All right, so instead of a separate step, I'm just going to integrate both sides. The antiderivative of y with respect to y is reversing the power rule. So it's going to be 1/2 y squared. I'm going to skip the plus c because, like we've discussed, I can just put it once in the whole problem. I don't need to really put it on both sides. The antiderivative of x is with respect to x is 1/2 x squared. Antiderivative of 1 is going to be x, and then we have our plus c. This right here is called the general solution. So if you're not asked to find a particular solution, you can stop here like we did last time or on the problem set. We want to find the particular solution. So actually, just to remind you, we're going to find C, and we're also going to solve for Y. You can technically do that in either order, but I recommend that you find C first, okay? So what I would do is find C next and save the solving for Y for the end. It's typically easier that way, not always, but typically. So to find C, what we're going to do is we're going to use the fact that when x is 0, y equals -2. So in here, I'm going to put the -2. If I were doing this as like homework or something, I would probably just go ahead and simplify this. And I probably wouldn't bother over here writing times 0 plus 0 plus c. But to show work for the first time you're seeing this, I think it's a good idea. So this is going to be 4. 4 times 1/2 is 2. This is 0. This is 0. We found c. So if I go ahead and plug into the general solution the value of c that we just discovered, we now have what's called the particular solution. I probably should not have boxed it, but this is the particular solution. Okay, so general solution. As long as I'm going to box the particular solution, I might as well box the general solution. And we're not finished with this one because of this little piece in the instructions that says y equals f of x. That tells us we have to solve for y at the end. So once I have my particular solution, we want to solve for y. So to get rid of the 1/2, we're going to double everybody. We're going to multiply both sides by 2. I didn't show it, but I times here by 2 and I times here by 2. And then to solve for y, we need to take the square root of both sides. Now, something a little different is going to happen here because we take the square root of both sides. We need to put the plus or minus. What we have to do is we actually have to choose the plus or the minus. Okay, we can't leave both. We choose the plus or minus, and it's not just the one we like better. It's based on which of those, because it's actually two equations. It's y equals the positive square root, and a second equation, y equals the negative square root. So we choose the plus or the minus based on which function passes through the given point, passes through the initial condition of 0, -2. So if we think about this, if we plug in 0 when we have the positive, there's no way this is coming out negative because that entire quantity out front is positive. So if we were to choose plus, we'd end up with just 2 at the end. That's not what we want. Oops, let me move that up. So if I were to plug in 0, if I choose plus and I plug in 0, I get y equals 2. That doesn't match. But if I choose negative, so let me test out. I'm testing out the negative instead. And if I plug in 0 there, then what we get in the end is the negative square root of 4, which is negative 2. That's what we wanted. So the final grand finale answer is you want to choose the negative. So you don't keep plus or minus. You don't just pick the one you like more. You have to make sure you actually pick the one that uses or goes through this point. So the final answer for this problem is y equals the opposite of the square root of x squared plus 2x plus 4. And now, and again, I do recommend when you're finding the particular solution, find C and then solve for y. Okay, so find C, then solve for y is my best advice. You technically can do it in the other order. And once in a while it's easier, but in most cases it makes your life harder. All right, we're going to do one more example like this. And so that's going to be number 6. I did not write this one out for you. So if you'd like to take notes, feel free. If you choose not to, that's up to you. And what we're going to do is we're going to find the particular solution. So the general solution is when you leave the plus C on there. So we're going to find the particular solution to the differential equation, negative 2xy squared, that passes through the point 1/4. Okay. So that's the example number 6. So this time, notice, it doesn't say y equals f of x. If it doesn't say that, then we don't need to solve for y at the end. All right, so that's good news. We can skip those extra steps. When it says find the particular solution y equals f of x, what they want at the end is they want y as a function of x. So they want y by itself with x all on the other side. All right, if this one didn't say that, if this one didn't say to solve for y, we could have stopped back here at the particular solution. So in the next example, we're going to get to skip all that extra stuff. All right, so on to number 6. We start with our differential equation using the skills from the last video. What we're going to do is separate the variables. It's called separation of variables because what we want to do is get all the x stuff on one side and all the y stuff on the other side. A common mistake in doing this is accidentally putting it as y squared instead of 1 over y squared. So just remember, to move the y squared, you're dividing y squared to the other side. All right, so I'm just going to show it real quick just in case, because it's such a common mistake. So what you're doing, since this is all multiplication, to move the y squared, you're going to divide y squared to the other side, leaving you with negative 2x dx. And instead of leaving it in that fraction form, we split that up. So keep y squared in the denominator, put dy to the side. And to hold the spot, the blank space there, you have to put a 1. Okay, so that's what just happened here. And now we integrate both sides. So when we go to integrate, I'm going to do the right-hand side first because it's a little easier for me. That's going to be negative x squared. I'm going to throw the plus c on that side. And that's because I reversed the power rule. So when I increase by 1, I have to divide the coefficient here by 2. Because I increase that by 1, so I get 2, divide this by 2, that leaves me with negative 1. You can always check by finding the derivative. The derivative of this is negative 2x to the first. And then for this side, I have trouble finding the antiderivative when it's in this fraction form. So I'm going to rewrite this as a negative exponent. And then I can go ahead and reverse the power rule. So I'm going to increase the exponent by 1 and divide by the new exponent. So I'm going to have a negative 1 out front. You can just write negative, but I went ahead and wrote negative 1 out front. And this is the general solution. If you were just looking for the general solution, this is fine. I prefer to put it back into a positive exponent. So I'm going to make a fraction with that y to the negative 1. And if you were looking for the general solution, you could stop right here. There's no need to go on and do any more work. All right, but we are looking for the particular solution that passes through the point 1/4. So what we have to do next is we have to use when x equals 0, y equals 1/4 to allow us to solve for c. So now we're going to go ahead and find the particular solution and that means we're solving for c. So I'm going to have negative 1 over 1/4 equals opposite of 1 squared plus c. This becomes negative 4, because if you same change flip it, you get negative 4. This is going to stay negative 1 plus c. This is opposite of 1 squared. That is negative 1. If it were negative 1 being squared, that would be 1. That's not what we have. The negative's out front. And then when we move the 1 over, we're going to get c equals negative 3. So for my particular solution, we take the general solution, and we just replace the c value with the constant that it has. Instead of writing plus negative 3, I'm going to write minus 3. And this is the particular solution. We do not have to solve for y because the directions did not ask us to. We'll know if we need to solve for y. It'll be this. It's so easy to miss, but it's this right here. If it says y equals f of x, that's what tells you to solve for y as a function of x. The directions for this problem did not have that, so we can leave it in this format. We do not need to solve for y. Thanks for watching.